So you've just been given a pesky problem like the following one on the screen there. So let's look at example A, where you've got to work out the oxidizing and reducing agents from the equation. Well, what a lot of you will have forgotten what to do is how to work out the oxidation number or the oxidation state. So first of all, let's take each of the reactants in turn. First, we've got MnO4-. Ignoring the 2 in front of it, what we do is we find out what the oxidation state of MnO4 is. Before this, if you don't know your basic redox rules, you best go back and learn your 10 rules for oxidation states. So we now know that the oxidation state of oxygen, when it's combined, is -2. And the overall charge on this ion is -1. So therefore, manganese added to 4 lots of oxygen, and since oxygen is -2, that's 4 lots of -2, and the overall charge on this ion is -1. Last time I looked, 4 lots of -2 is -8, and the overall charge on the ion is -1. If we now add 8 to both sides to get rid of the 8 on this side, so +8 -8 equals 0, -1 plus 8, manganese has got an oxidation state of +7 in MnO4-. If we now look at the oxidation state of the oxygen, of the sulfur in the sulfur dioxide, using the same principles, let's see what the oxidation state of the sulfur is. This time, the sulfur is combined with oxygen, but there is no overall charge. It's a compound, not an ion. We know again that the oxidation state of oxygen is always -2, and therefore sulfur plus 2 lots of oxygens, which is 2 times -2, but this time the overall charge is 0. There is no overall charge on sulfur dioxide. So sulfur -4 equals 0. Sulfur, if we add 4 to both sides, 0 plus 4, oxidation state of sulfur is +4. What we now do is look at the products, and if we go over here and have a look at the oxidation state of manganese, you can see here that, again, ignoring the coefficient in front, it's +2. So the oxidation state is the same as the charge on the ion, and therefore its oxidation state is +2. If we look at the oxidation state of the sulfur in SO42-, the sulfate ion, again using the same principles, so it's SO42-, then sulfur plus 4 lots of oxygen, and oxygen is always -2, equals -2. That's the charge on the ion. Sulfur -8 equals -2. Add 8 to both sides to cancel out the 8 on this side, so that's -2 plus 8. So sulfur has now got an oxidation state of +6. So we can see that sulfur has changed in the reactants from +4 to +6. It's gone up the ladder, so therefore the sulfur has been oxidized. Where there's oxidation, there's got to be a reduction, and manganese has gone from +7 to Mn2+, which is now +2. And therefore it's gone down the ladder, it's been reduced. Therefore, remember, the oxidizing agent is a species which rips electrons off something else, it itself becoming reduced. So we can therefore categorically state that MnO4- is the oxidizing agent, because it's taken electrons and become reduced itself. The sulfur, on the other hand, must therefore be the reducing agent. It itself has become oxidized, it's lost electrons, and therefore it's given them to something else. It's gone from +4 to +6. So sulfur, or we can say that sulfur dioxide was the reducing agent.